So, welcome to the podcast of the European Society of Anesthesiology and Intensive Care. I'm your host, Professor Thomas Scheeren from Edwards Lifesciences, Germany. And today we will be speaking about intraoperative hypotension when using Hypotension Prediction Index software during major non-cardiac surgery. And here we have invited Professor Bernd Saugel from the University Hospital Hamburg-Eppendorf in Germany. This episode, by the way, is kindly supported by Edwards Lifesciences. So, Professor Saugel, we learned in the recent decade that there is an association with intraoperative hypotension, mostly defined as a mean arterial pressure below 65 millimeters of mercury, and adverse patient outcomes, such as acute kidney injury, myocardial injury, and even death. In the EU-HyProtect registry, where you were the leading investigator, you were looking at the incidence, duration, and severity of intraoperative hypotension when using HPI software. So my first question would be, can you tell us why you believe it was necessary to set up this registry?
Well, first of all, thank you for having me. Thank you for being the host, and it will be a pleasure to talk to you about the EU-HyProtect registry. And coming back to your question, well, back then when we started discussing this study, the predictive monitoring software, the Hypotension Prediction Index software, was published, was validated in first observational studies, of course. And there were a few randomized control trials with kind of contradicting results. One small randomized control trial published in the JAMA showing that there is a substantial reduction in hypotension when you use predictive monitoring. Another one, substantially larger trial, but still a small trial from the Cleveland Clinic, showed that there is no difference in hypotension when you assign patients to having predictive monitoring or not. So we were thinking about different trial designs. We were thinking about doing another large randomized control trial, or we were thinking about other study designs. For example, building up a registry, building up something that you can do without randomizing individual patients. And we felt that it might be necessary to have a look at what really happens in the operating rooms when you use HPI. And therefore, we conceived this study to build up a huge European multi-center prospective observational registry in patients having non-cardiac surgery, with the primary aim to simply describe the incidence, duration, and severity of intraoperative hypotension when using this predictive monitoring.
Thank you. And I read that this registry was intended to create so-called real-world evidence. Can you explain why there was a need for real-world evidence, and what's the difference as compared to those RCTs or randomized control trials that you mentioned?
Yes, of course. When you do a randomized control trial, randomizing individual patients, there's a lot of administrative work around it, a lot of contracting. It takes a lot of time. It is very expensive, and trials may not necessarily reflect what happens in the real world in the operating room, because usually centers do not include huge numbers of patients. There may, even it's a randomized control trial, there may still be some kind of a selection bias, because clinicians or researchers tend to include a certain subgroup of patients who are easily give informed consent or whatever. So there are a randomized control trial for me still is the best way to study an intervention and to study whether there is a causal relationship. But back then we thought, okay, there are the first randomized control trials, but what we don't have the experience from the real world, from the field, from the operating rooms. How much hypertension is there if you use predictive monitoring? And that is why we came up with this study design, a real world evidence study, a registry study. And there are some advantages, including that you can include a large number of patients in a relatively short period of time, because you basically can include a lot of patients because there's no complicated treatment protocol, and the speed of recruitment can be very high. And we build up a network of of hospitals across Europe in 5 European countries who were first of all experienced in using the predictive monitoring. We may come back to that later, but centers that also have the infrastructure of for being part of a study like this. And yeah, we may come back to that, but that was quite successful.
Yeah, great. So let's talk about the timeline in a second. But first, can you tell us about these participating centers? How did you select these?
Yeah, those were centers in which clinicians already used predictive monitoring. So we wanted to avoid that there's some kind of a learning curve within the study, so that clinicians first need to become familiar with the technology and the predictive value per se, and then you know that there's a secondary screen which suggests what underlying cause hypotension may have. So it's not complicated, but at least you need to be familiar with the system, and therefore we only included centers that already used predictive monitoring. And this is a strength of the registry, because it shows you what you can do with the technology when you really know how to use it. And on the other hand, of course, it's a limitation, because this not necessarily translates to centers in which clinicians are not used to do that. So our inclusion criterion for the center was that clinicians were familiar with predictive monitoring.
All right. Thank you. So coming back to the timeline, which you already mentioned. So how long did it actually take to recruit the patients, which was quite a substantial number, more than 700 patients you included, and how long did the study take from the beginning, let's say from starting the study, the paperwork, the applications and so on, to finalization of the study being the publication, which was about 2 years ago, as far as I remember?
Yeah, well, we included 749 patients in 12 centers in 5 European countries, in France, in Germany, in Italy, in Spain, and in the UK. And the timeline was quite impressive. So we included the first patient in the registry in September 2021. So this was first patient in. And we included those 749 patients until May 2022. So this means we included all of those patients in 9 months.
And that was still COVID time, right? As far as I remember.
That is correct. But yeah, at least in our institution, even during the pandemic, we almost worked at full capacity all the time. Of course, there were a little bit... it was during the COVID time, but yeah, despite COVID, we were able to do that in 9 months. And then we published the protocol September 2022, and then after 18 months after the first patient entered the registry, we had the full publication showing the main results.
Excellent, congratulations. And that would not have been possible with a randomized controlled trials, probably.
Randomized controlled trial probably would have taken longer, so this is something that is, well, it's a theoretical question, we don't know, but from our experience, randomizing individual patients takes longer than just including consecutive patients in a registry, yeah. Excellent.
So now let's talk about the results. So what did you find in terms of hypotension? You were looking at the incidence, the severity, and the duration. Can you tell us about those results?
Of course. Perhaps it's important to first describe the primary endpoint. The primary endpoint is the median time-weighted average mean arterial pressure below 65. And this is something that requires a little bit of explanation. So we know from a lot of registry analysis that the population harm threshold for organ injury is a mean arterial pressure below 65. So this is where the 65 comes from. And then, of course, it makes a difference how much below 65 you are and for how long you are below 65. And to capture both of these things, the severity of hypotension and the duration of hypotension, you can have a look at the area under certain thresholds. So whenever you are below that threshold, you start counting how long does hypotension take, and you start looking at how severe is hypotension, and then at the end you kind of sum up all those areas below the curve. And because different surgeries have a different duration of surgery, you need to normalize for the monitoring time. Otherwise, the duration of surgery may influence your results. So then you divide this area under the threshold by the duration you monitor the patient, which usually is the duration of surgery. And then you have the median, the time-weighted average mean arterial pressure, and our primary endpoint was the median time-weighted average. We then also looked at another secondary endpoints, like time-weighted averages below other thresholds. We looked at the number of episodes below a couple of blood pressure thresholds, absolute duration, relative durations, and we had some exploratory endpoints related to organ injury. And if we come back to the primary endpoint, so the median time-weighted average mean arterial pressure below 65 was 0.03 millimeters of mercury, and I think we need to put that into context because it's a number that we are not used to. So 0.03 is very little hypotension, and but you may compare it to other studies or trials. And for example, we were just talking about a study from the United States where they found that an observational quality initiative study where the time-weighted average was 0.6, I guess. And if you look at other randomized controlled trials on predictive monitoring, for example, in the control groups of those trials, time-weighted average mean arterial pressure was, for example, around 0.4 or 0.3. So we reduced that by a factor of 10. So our primary endpoint, 0.03, and the time-weighted average is very little hypotension.
So you almost eliminated hypertension, if we may say.
There was very little hypotension, yeah.
Okay, thank you. So, and you also already compared that in terms of what has been published in the literature. So even in those studies who did use those technology, it was even lower than that. And this is maybe due to the fact that the users were already experienced with that technology. Would you agree with that conclusion?
Yeah, I would agree. What we cannot say is that there's a causal relationship between that type of monitoring and the result that there was almost no hypotension. But what we can say is that in those centers where clinicians were experienced with using this type of predictive monitoring, in patients who had this predictive monitoring and who were treated by those clinicians, there was very little hypotension. And as you already mentioned, we cannot control it or we cannot compare it to a control group because it was not a randomized trial, but we may do that looking at historic data or propensity score matching our patients. But at the moment, we can simply say there was very little hypotension when predictive monitoring was used by experienced clinicians.
Excellent, thank you. Besides those, how I call it, the hypotension metrics, you also looked at exploratory outcomes, bearing in mind that the study was not powered for these, of course. Exploratory outcomes like acute kidney injury and myocardial injury. What did you find? Can you tell us about what you found there?
Yes, of course. Before I come to that exploratory outcomes, I may say a word about a few more secondary endpoints that maybe listeners may understand better than the time-weighted average. So if we, for example, look at the number of episodes that were longer than 1 minute below a mean arterial pressure of 65, this was a predefined secondary endpoint. This median number was 1. So the median number of more than 1 minute episodes was 1 episode, which of course is not much. And if you have a look at the median absolute duration below a mean arterial pressure of 65, this was 2 minutes. So when you think that the inclusion criterion was surgery expected to last longer than 120 minutes, then if the median duration below 65 was 2 minutes, again, it reflects that there was relatively little hypotension. And regarding the organ function outcomes, which of course are exploratory because the study was by no means powered to investigate this, and there's no control group to make any assumption that there's a causal relation. But we had around about 9% of the patients developed acute kidney injury, according to the KDIGO definitions, which is lower than in other studies and trials, including than the rates reported in other studies and trials. But of course, you cannot directly compare those patients, our patients, to the patients in the other studies. But it was 9%, and we used creatinine on an as availability basis. So if it was if there were creatinine measurements for clinical reasons, we used those, and the same is true for myocardial injury. So I would say that we massively underestimated the rate of myocardial injury, because that is always the case if you do not systematically measure troponin. But myocardial injury occurred in around about 3% of the patients. It is what it is, and we may get better insights into this if we are able to do post-hoc secondary analysis, looking at other data sets that may include patients who we can propensity score match to our patients.
So I get your argumentation about the myocardial injury, because you're saying, first of all, we don't have exhaustive number of measurements in those patients. I think it was around 200 patients who had a troponin measurement of that 700 patients. So this is maybe too low to draw any conclusions from. And the second reason may be because we all know that myocardial injury might go silent, so it's not detected by the patient, so it's not triggering troponin measurements to be taken by the clinicians taking care of their patients. But for the acute kidney injury, I'm not sure if I would agree, because first of all, you did have in almost, or in the majority of patients, you did have creatinine measurements. And for those where we don't have, is it not fair to conclude, if the clinicians did not see a reason to take a creatinine measurement, there was probably no reason indicating that there is a kidney problem. So they probably had no normal urine output, they had no whatever signs of kidney insufficiency. Would that be a fair conclusion, or would you say as a scientist, be careful?
It's an assumption. It's you can assume that. You may say that if there's no creatinine value in the system, then there was no kidney problem. As a trialist, I would say if I use acute kidney injury as an endpoint in a trial, you need to have a look at creatinine systematically, and the same is true for troponin when you look for myocardial injury. You would of course notice if a patient has renal replacement therapy, but most of the patients having postoperative acute kidney injury, of course, are captured through the creatinine values. So I wouldn't agree completely from a methodological perspective. I would love to have all the creatinine values systematically, but it's probably a fair assumption that there may be not stage 3 kidney injury if there's not a single postoperative value, but this is more or less an assumption.
Okay, thank you. So thank you for sharing that results with us. So summarizing, what would be the key messages you would derive from this registry?
Well, in terms of the hypertension metrics, I would say that the incidence, duration, and severity of intraoperative hypotension was low. So there was little hypotension in patients having predictive monitoring, treated by clinicians who are experienced with using predictive monitoring. So in patients included in this registry, the primary outcome, the time-weighted average mean arterial pressure below 65 was 0.03, which again is kind of an abstract number for most of the listeners, but if you compare it to previous research, you will see that it's very, very little hypotension. In terms of the other exploratory outcomes, I would say we need, first of all, more analysis. We need to dive deeper into our data and to draw a final conclusion that predictive monitoring actually causes a reduction in postoperative complications, organ injury, we would still need another study trial design.
Okay, thank you for sharing the results of this EU-HyProtect study with us. And I understood there is more to come from this study. Even you will further deep dive into the data and see if there are other interesting findings to be reported. So we're looking forward to that, and maybe even follow-up studies based on those findings. So thank you very much, Professor Saugel, for this interview, for sharing this interesting findings with us. And the paper is open access published, so everyone can download it for free if he wants to reread the results. I would also like to thank everyone for listening to this episode, and to remind you that the ESAIC releases monthly podcasts on the ESAIC website and on various other streaming platforms, and we hope you will join us also for the next one. Thank you very much.